Hello everyone, this is question 24 from paper 1 from IGCSE 2023, and it's a vector question. So it says OAED is a quadrilateral, and it tells us all the information there. O to A is 2A, O to B is 2B, D to E is 7A plus 3B. And it tells us that the ratio of A to B to B to D is 1 to 2. The point C on AB is such that OCE is a straight line. Use the vector method to find the ratio of O to C to E. Okay, so let's just imagine the straight line on there. So let's just annotate this with a straight line. It might not work out exactly correct because of the scale, but what they're saying is, they're saying that in essence, that is a straight line where that there is the point C there. Okay, perfect. Right, let's have a look. Now, remember, the vector method essentially involves finding two different routes that start at the same point and finish at the same point. So I'm going to find two different routes going from O to C. And remember, it doesn't really matter, how you do this, but because we've got to find the ratio of O to C to E, it makes sense to find two routes going from O to C. It would have been perfectly acceptable to find two routes going from C to E as well. But first of all, let's have a look at the routes to go from O to C. Now, I've decided to do a rather circuitous long route here. So the route 1 is to go from O to C, is first of all to go to O to B. So I'm indicating with the cursor here up to there. Then, once I've got to B, I'm going to go B to D. So as I'm indicating with the cursor here to D. And then I'm going to go from D to E up there. So what I'm saying is that one way of getting from O to C is to do some fraction, lambda, of going up there, along there, and up there. So that's my route. Okay, that's my first route. So what do we know? O to B is 2B. We know that B to D, because of the way we're told that the ratio of A to B to B to D is 1 to 2, we know that going from B to D is two lots of A to B. And going from A to B is going to be minus 2A plus 2B. So minus 2A plus 2B. And then finally, D to E, we're told, is 7A add 3B. So that's my route. So all I need to do now is expand all the brackets and collect like terms. So I'm going to expand the brackets. So 2 times minus 2 is minus 4. 2 times by 2 is 4. And then collect like terms. 2B add 4B add another 3B is 9B. And minus 4 add 7 is 3. Okay, so that is my other route. That's my first route, rather. So what's my second route going to be? Well, my second route to go from O to C is simply just, I'm going to go from O to A. So, and then from A, I'm going to do some fraction of A to D. So to go from O to C, it's going to be some fraction of A to D. So let's think about that then. O to A, we're told on the diagram, is 2A. Some fraction of A to D. Well, A to D is going to be three lots of A to B because of the way that we've got the ratio 1 to 2. So to go from A to D is three lots of A to B. And we know that A to B is minus 2A add 2B. So that's fine. So I can expand everything here now. Give me 2A minus 6 mu plus 6, minus 6 mu A plus 6 mu B. Gather together my A and B terms. 2A minus 6 mu A and then 6 mu B. So we've got our two routes, okay? So that's my route 1, and this is my route 2. So we're going to put route 1 equal to route 2 now. So there's our route. Oh, goodness, the pencil lead's dropping out, dear oh dear. So we're going to put the route 2 equal to, the two roots equal to each other. And then we're going to basically equate the coefficients, okay? So looking at our two roots, let's first of all think about the coefficients. Let's equate the coefficients of A. So this is equating the coefficients of A, and this is equating the coefficients of B. So equating the coefficients of A, then, just having to a little bit of a pencil rearrangement here as the lead's just fallen out of my pencil. There we go. Okay, so here we go. Now let's have a look. So we've got the coefficient of A is going to be 3 lambda A from root 1, and the coefficients of A from root 2 are going to be 2 minus 6 mu. So we have 3 lambda equals 2 minus 6 mu. Okay, so that's our coefficients of A. Our coefficients of B are going to be 9 lambda, and we're going to have is equal to 6 mu, because we have 6 mu. So we've just equated our coefficients of A and our coefficients of B. So let's look at the coefficients of B equation first. The coefficients of B gives us that 9 lambda is equal to 6 mu. So we can say that lambda is equal to 6 over 9 mu. That's one of our roots. Here we have 3 lambda equals 2 minus 6 mu. So I'm just going to sub in the fact that lambda is equal to 6 over 9 mu. So 6 over 9 mu is what our lambda is. And then 3 times by 6 divided by is 18 divided by 9 is 2. So we have 2 mu equals 2 minus 6 mu. Adding that over there, so we have 8 mu equals 2. So mu equals 2 over 8, which is a quarter. So now we know that mu is a quarter. We can sub that into our other equation. And when we sub that into our other equation, that gives us 6 over 9 times a quarter, which is going to be 6 over 36, which is 1/6. Now let's think about this. So our lambda, what was our lambda? Our lambda was originally the fraction that we need to go along O to E in order to reach C. Okay, so basically we said that going from O to C was lambda of O to E. And we've just found out that it's a 6. Okay, so what that means is if you have to go 1/6 of the along the length of OE to reach this point here, it means that this bit must be 5/6. Okay, so what we're saying is that on this diagonal that we've got here, with O there and C there and E there, we've just found out that we need to go 1/6 along that line in order to reach C, which means that this bit must be 5/6, which means in turn that the ratio of O to C to E must be a ratio of 1 to 5. And that's our final answer for that one. That's our ratio there of 1 to 5. I hope you found that helpful, and I will see you in the next video.